Welcome back, everybody, and in this lesson we're going to talk about the derivative of a composition. So before we do that, I want to remind you what a composition is and the notation for it. So typical notation that you probably experienced in our pre-calc course is like this. So f is a function of g, which is a function of x. Our current textbook uses this notation, f of g, for example. So if we were going to say f of g is equal to 1 over x minus 5, we could say that f of x is equal to the 1 over x function and g of x is equal to the x minus 5 function. So putting that together using the old notation, it would be f of g of x is equal to f of x minus 5, and similar to what we did for derivatives in the last chapter, f of x plus h, we would basically substitute in x minus 5 into the place of x in the f function. So this would be 1 over x minus 5, and so we can think of that function as a composition of two functions. So what we're going to do right now is we're going to do a sort of proof by example for finding the derivative of a composition. So what you see here is a graph of several functions. The f of x function, 1 over x in red, the g of x function, the line 2x minus 3 in blue, so we have g of x, and the composition f of g in green. And finally, pardon the spacing here, the tangent to f of g at x equal 1, and that is dotted, and I am not going to label that, just going to say that that's the black dotted line. So we're going to find a few things here. The first thing that we're going to find is we're going to find g prime of 2. So g prime is the derivative of 2x minus 3, and that would be 2, and that's a constant, so g prime of 2 is equal to 2. We're also going to evaluate g of 2. So the g function is the blue function, so we look down here to where x is equal to 2. You could see the point is labeled there. So when x is 2, g is equal to 1. Now we're going to put this all together in a minute. The next thing we're going to do is we're going to find f prime of g of 2, and so that would be f prime of 1 because g of 2 is equal to 1, and we're going to show what that's equal to. So f prime of 1 is the derivative with respect to x of the function 1 over x, and we want to evaluate that at x equal 1. Well, that can be written using exponents. We can say that's the derivative of x to the minus 1, and we're going to evaluate that at x equal 1. We can now use the power rule for that. So the power rule is going to be negative 1 x to the negative 2, and we are going to evaluate that at x equal 1. So simplifying that or rewriting it with a positive exponent, that would be negative 1 over x squared evaluated at x equal 1, which is negative 1 over positive 1, which is negative 1. The next thing we're going to do is we're going to find the derivative of f of g at x equal 2. Well, as you can see, the dotted line is the tangent to f of g at x equal 2, so we basically just need to find the slope of that, and so we're going to take the change in y over the change in x, so we're going to take 1 minus 5 over 2 minus 0, and I'm using these 2 points that I'm going to highlight in yellow right there and right there to figure out that slope, and that turns out to be negative 2. Alright, so now we're going to put all this stuff together, and we can see that the derivative with respect to x of f of g at x equal a is equal to f prime at g of a times g prime of a. Now you may be thinking like, okay, well, how can you show me that? Well, so let's try that at x equal 2. So the derivative with respect to x at x equal 2 of the composition f of g should be equal to f prime at g of 2 times g prime of 2. All right, well, f prime of g of 2 we found was equal to -1. We did that up at the top. G prime of 2 is equal to 2. We did that up at the top, and that's equal to -2, which is equal to the derivative, which we found by finding the slope of the tangent line to f of g, of -2. So by no means is this a proof, and by no means should you be finding a derivative this way every time you have to find the derivative of a composition. What this is an example of how the rule works, and so what we are saying is that the derivative of the composition f of g of x, written in either form, either the form that we did in pre-calc or the form our textbook uses, is f prime at g of x times g prime of x. Another way of looking at that, let's say if f is a function of t, the derivative of f of t of x is f prime at t of x times t prime of x. You can think of this first one as df, the derivative of f with respect to t, and this other one as the derivative of t with respect to x. And you might think of these two dt's canceling out and giving you the result of df dx. So I'd like to do a few examples. One is more of an application word problem sort of thing, and the other one is just a straightforward, here are the functions. Let's find the derivative using the composition rule, which, by the way, is also called the chain rule. So here's the situation. Violin production A of V. A of V denotes the average cost in dollars to produce a student violin when V violins are produced. V of T represents the number of student violins produced in a year. Suppose that in 2011, 10,000 student violins are produced and production is increasing by 100 violins per year. Also suppose that in 2011, the average cost to produce a student violin is $142.10, and the average cost is decreasing by $0.15 per violin. We're going to start out with a diagram to represent the relationship there, and this is a common approach to functions. You have an input at the top, t, for the function v, and you have an output, v of t, for that, so I'm going to highlight that in yellow. So violins as a function of time, but then you also have that go into the input for the a function, which I am going to highlight in blue, and a is a function of v, which is a function of t, and that is the cost to produce those violins. So a is the average cost in dollars to produce a student violin, but that depends on the number of violins, but the number of violins depends on time. So A we addressed in the diagram below. B says to calculate the rate of change of the average cost, that's A, to produce student violins with respect to time. So basically, find the derivative dt of A of V of t. Okay, so we're just going to use our rule up at the top, and our rule up at the top says a prime of v of t times v prime of t is what we need to find. And we are going to evaluate that at t equal 2011. So let's write a few things down. This is going to be a prime of v of 2011 times v prime in 2011. All right, we need to go back up to the top and find that information. So v of 2011, suppose that in 2011, 10,000 student violins are produced. So this is going to be a prime of 10,000 times v prime. Well, v prime of 2011, it says also suppose that in 2011, the average cost to produce a violin is $142.10, and the average cost is decreasing. Production is increasing by 100 violins per year. So that's the V function. So V of 2011 is equal to 100. So we're going to write that down, 100. Now, the only thing we need to find is the derivative of A at 10,000. So suppose that in 2011, 10,000 student violins are produced and production is increasing by 100 violins per year. So that's V's rate of change in 2011. Also suppose that in 2011, the average cost to produce a violin is $142.10, and the average cost is decreasing by $0.15 per violin. So this is a negative $0.15 per violin, and the units for V prime of t is going to be violins per year. So in the end, we have a derivative that is equal to negative $15 per year for the derivative of A of V of t. Calculate the rate of change of the average cost to produce student violins with respect to time. So average cost is changing at a rate or decreasing at a rate of $15 per unit time per year in this case. And for the last example, it's strictly just two functions. F of t is equal to 3t squared. T of x is equal to 4 plus 7 ln x. Find f of t prime. So that is the derivative with respect to x of f of t of x. So our rule again is f prime of t of x times t prime of x. So that is f prime of 4 plus 7 ln x times the derivative of t prime of x. So t prime of x, we'll write that down. In this case, it might be easier to think of this as df dt, so that right there, times dt dx. So let's take the derivative of f with respect to time, and the derivative of f with respect to time is 6t, 3t squared, we're using the power rule and the constant rule there, times dt dx. So dt dx is going to be the derivative of 4 plus 7 ln x. The derivative of that with respect to x, the derivative of 4 is 0. The derivative of 7 ln x is just 7 times 1 over x. Now the only thing we have to do is get this all in terms of x, because we're taking the derivative with respect to x. So we have 6 times t, but t of x is 4 plus 7 ln x. And then we've got everything in terms of x times 7 times 1 over x. Now, often that would be simplified we would have something like this. 6 times 7 is 42, times 4 plus 7 ln x, all divided by x, but you can leave it unsimplified as far as I'm concerned. Just make sure that when you're checking your homework answers that you can take your answer and put it into the same form as the publisher's answers.